I will translate this again. I will translate here. Sad. Well, a body with mass 150 grams is launching horizontally. So the same thing ever. Launch horizontally, angles and velocities and the same equations is the same thing ever, man. So I am sure you is able to do the question 2 because the question 2 is very easy. It's like the others. This question here seems to me more hard. Okay.
Yeah.
Okay. So horizontally, since I don't know this question, this word since, but okay, I will put here since the origin, the origin, the referential hit the ground with a velocity v equals. But I will draw this. Calculate A or 3.1 move equation. Do you wanna know the move equation? The point of the impact. C. Energy. Energy is new to me because we don't speak about energy yet, but you already do you already see this in the class, in your class, your physics class? Did you understand? Did you learn about energy?
I do not remember.
Do you know? Do you don't remember about the energy? Like kinetic energy, potential energy. Do you don't remember your teacher speaking about it?
I don't remember.
Okay. But we need to do this now. I will teach you. Connect. I don't know. Connect energy of the mass to 25 meters to the ground, and the range of the angle between the velocity and the vertical in the instant of the body hits the ground. Okay, very cool. The equation of the move equation. Man, this is the information about velocity. Okay, so I will write here this again, but you will do the first problem. Okay, you will do the move equation because you know the equations. V0x is 50, right? And V0, the initial velocity, and y is minus 30. You already know the informations about horizontally moving and vertically moving. So I want you try to write the equations in the first problem. But remember, a move is the position equations, okay? They want the position equations in the problem A. Okay, so try to do this. Try to do this and send me a photo.
Okay. So you want the time?
No, we don't want the time. In the first question, we only want the equation, only the equation.
So
And the
x
equation will
equal,
depends of t. In other words, we don't need the value of t.
so it will be x equal v0 x t.
Okay, but you are saying the velocity equation, but I want the position equation, right? You know the position equation. To horizontally is x equals x0 plus v0 xt, and y the same thing, but we have the acceleration, right?
Yeah.
Yeah, so you just put the values in these places, the places of the position and velocity and acceleration, but time will stand in the equation. You don't change the time because the time is a parameter, okay, of the equation.
Is x0 equal to 15 and v0x also equal to 15?
0x is 15, but the x0 is 0 because you need to pay attention in this point here of my translation. Since the referential, so this movie starts in the referential, right? The referential is the position 0, 0. 0 to x is 0 to y, okay?
Yeah, okay.
Okay.
And is A going to be -10 or this 10?
Negative 10 because we consider up positive.
I'm done.
You are done? Send me the photo.
Yeah, I sent it.
You send me, but I don't see. Let me see. Um, we have a problem here because if you look more with more attention, with more concentration, you will see the sign here, man. So the initial velocity on y is negative, right? And in your equation, you put positive sign. Did you know?
What is going to be negative?
This sign is negative, right? Minus
Yeah.
30, and you put here positive.
Yeah.
Paying attention, sign is a so easy trick, and you, my guys, my students, ever forget. But okay. 3.2, the point of the impact. So again, I suppose you need to draw this. Okay. I wanna you try draw first without my reference. Okay. Try draw you first. If you draw wrong, no problem. No problem. Just try. Send me a photo, and um I will see if you are right or not. Okay.
Okay. I sent you a photo. So in this situation, I'll have to write 15 at the arrow, right? 15 meters per second at the arrow.
Yeah. Let me see. Just a thing. Just a moment, man. Let me see. Just the thing. Yeah. This, but very simple. Your draw. You need to be more precisely about the velocity because it's the information you have, right? So okay, you put the mass, the initial vector in the right position, but you need to be more, I don't know.
Yeah, I just wanted to ask you, like on the arrow, I said put 15 meters per second.
What arrow? Well, X arrow is 50, right? And you have, you, this is a little strange to me. Just a second, I need to think about one thing. This is very strange. I note something now with your draw. Because when I saw this, I suppose, I need to draw a vector down in Y, right? Because the sign is negative. But seems to me this movie is a bidimensional movie, or in other words, this parabolical movie, right? I suppose something like this. Again, it's ever the same thing, but the minus sign is very strange. So I
Yeah.
suppose a strange thing here. I suppose the negative side is to up in Y. Okay.
Yeah.
So this make more sense to me now. And because this we have here, oh my God, we have here our Vx and here our Vy. Our arrow is side of our arrow in Y is to up. So because it's to up and I decided the minus is to up 2, our Vy makes sense to be minus 13, minus 30, minus 30, 30 negative 30. Okay, so this is the thing here. This is the movie. Okay, with our V0x and V0y. What more else? Let me see. For this instance, is only this. Our draw is here. But to understand the point of the impact, you need to remember. Man, sorry. I understand everything wrong here, and I suppose I teach to you wrong too, because this information here is not the initial velocities, man. Sorry, I am wrong. Because the question say to us, this is the velocity. The mass hit the ground, okay? In other words, is the final velocity, man. Sorry, I understand this wrong the first time. So, out here is wrong. Sad, man. Sorry. Sorry. I am wrong here, but I will do this. But if this was, if this were the initial velocity, you are right, and me too, but it's not. So I will do the first. The equation of the trajectory. Bem, I don't know. I don't know because I don't know the initial velocity, but they say something about the horizontal, launch horizontally. So I suppose the real movie is not what you draw, but something like our body is here, and we have a initial velocity only in the horizontal. We already did some things like this in other class, right? This is the initial movie, and we have a movie, a development like this, parabolic. Okay, because I read wrong this problem. But you understand now? Do you see my error?
Yeah.
Okay, you understand? Amazing. So this is the initial, and here I will put here the E, the initial, and the key F of finishing, and we have the velocity here. The velocity in the finish, in the end of the problem, is these things here. So here we have a velocity to down and another velocity to right. Here is our 30, and here is our 15. Minus 13, right? Minus 30. So again, man, I have a question to you. Let's reset this error and let's think about this problem now. We have this movie, right? And we know the x velocity here. So we know we don't have acceleration x. What's the velocity here? Remember, we don't have acceleration and x in the horizontal.
It's 15.
Yeah, it's 15. It's 15 too, because our velocity never changes in x, right?
Mm-hmm.
So I will not draw this here. I will only draw the equations now. I will first write the x equation. Here, they say something about the since the referential. So it's a little strange to us, but the referential is here, okay? Is here in this point. This is the referential. This is not the referential, right? This is only the ground. Here is only the ground, it's not the referential. Zero, the point 0, 0 is here.
Yeah.
Okay. So here we have 0, and our velocity is 15 t. So more cute, more simplified. This is our equation x. So in y, we have that equation. I write a lot of times. So I will just put the things here. 0, and y, it's our initial velocity, and y. Our initial velocity in y is 0, because we have only a horizontally launching. So 0. And we have minus 20 squared. So just like that. This is our equation, x and y, okay? Easy. Easy if we understand the problem, right? So let's speak about this problem again. We only have the velocity with the body, hits the ground. Here we have this velocity. Initially, we have only a horizontally moving, but the gravity take this body and goes down to it. So we have this move. And because this, we have acceleration move in y, no acceleration move in x. And I put the things in the equation because our velocity don't change in x. And we don't have initial velocity in y, just the acceleration. So this is our equation. Okay. B, the coordinates of the impact. What you need to do now? I will not do this for you, but you need to remember and try for Thursday. You need to remember we have the velocities. So pay attention. You will do this. To understand the point of the impact, man, pay attention. You need to know the time with the impact, right? Agree with me?
Yeah.
Okay. How we will, how do we know this time? We know this time because we have the velocities. So you can use the equation of the velocity. V equals V0 plus AT, right? So use this equation to take the time, to get a time, and put this time in these equations. These equations here, okay?
Yeah.
So it's enough to me. If you get this, this will be amazing. So try. You need to use the velocities to get the time and put the time in the position equation, right?
Yeah.
So man, this is for you. You try this until Thursday and send to me this, okay?
Okay.
Okay. Good luck for you. See you Thursday. Bye-bye.
Thank you. Bye.
Bye.